I'm Sujit Das, business consultant with IBS. Today I have my colleague Sharath Nagaraj joining me. Welcome Sharath.
Hi Sujit, thanks for having me here. Excited to be part of this talk.
Yeah. So let's talk about dynamic revenue management, as it is the hot topic and the whole industry is looking forward to it.
Right.
But Sharath, generally airlines have rule-based dynamic pricing in place for several years, and that is the reason passengers are able to see different fares for the same seat on different days, right? So what innovation do you bring using AAML?
You're absolutely right, Sujit. This dynamic pricing is nothing new to the airline. But the problem that airlines have with dynamic pricing is that it's a two-pronged problem. One is it's heavily rule-based, and two, it requires a lot of manual intervention. When I say it's rule-based, what I mean is, like, let's say if you have a 50-seater aircraft and it's all economy seats, you actually bucket those into different buckets of seats, and you assign different price buckets for each of them. And then you open and close them based on demand and a lot of things. So it's like an inventory control game, and they do this by means of some pre-written rules using something called fare class and fare basis codes. And then all of this is filed into, for most airlines, it's filed into a system called ATPCO, from where the fares are published and reaches everywhere. So this is, in a sense, is dynamic, but underlying this, it's all predefined written rules, and it's static in a way. So, and the other thing is, there's a lot of human intervention here. Like, there are an umpteen number of analysts and revenue managers sitting and doing this on the background, tracking the prices and the demand on a real time and making adjustments. So all in all, this is what we see in an airline. And what you can see here is that you cannot tap into the whole revenue potential with this kind of a predefined rule-based system. There are still a lot of untapped potential in this PQ graph that you can actually reach to. You cannot simply write rules for every possible combination, right? But AI and ML can actually find patterns within patterns with the help of a lot of features that go into this. And that's where our dynamic RM solution can actually go into these untapped areas and unearth the potential revenue improvement that we can actually look for.
I was wondering how you start attacking data problems. I know you start with data extraction, but can you please throw some more light into this area?
Definitely. Typically, for such a problem, we start with 5 to 6 years of historic data, and we look for features like days to departure, the flight date, the booking date, and you get all the day-related features from that, like the day of the week and the day of the year, etc. And then you look for the length of stay, whether there's a weekend in the length of stay, etc., etc. So these are some of the features that we look for, and all of them are not in one table in a very nice format for you to work with, right? These lie across different tables. These are coming from multiple systems, sales, inventory systems, etc. So the idea is to actually bring them all together, do the data extraction of the raw data from all these tables, which are probably lying in multiple tables, and then clean it, process it, and convert it into a format which is actually good for the data scientists to work with. So that's how we work. And then we have something called our own airline specific data analytics and modeling studio, which we use for this. And this is for airlines with a lot of historic data. And we also work with airlines, startup airlines, where you may not have such historic deep data. We have a different approach for that as well.
All right, let's now look into airlines with historic data, and I'm curious to know how this workflow will look like.
Yeah, so I mentioned briefly about the data analytics and modeling studio. So here we can see that we actually process or take the raw data, and then we use our studio, which is very airline specific, and then do the ingestion and then the data pre-processing here, which then leads into the modeling part, where we actually do the clustering and the classification, as you can see here, which then integrates, these models then integrates with the dynamic RM solution. That's what happens here. And then we add the context of load factor and competition data and all that context on top of it. And then we serve this as prices, using our APIs to the airlines that we need. So this is how typically the workflow will look like.
Could you please talk more about data pre-processing part and what are the intricacies involved in this stage?
Sure. So typically, as everyone says, this is where we spend a lot of time. Almost 80% of our work goes here, And this would involve, as I said, the data is coming in from multiple various systems. And what you need to do is go through that raw data and then clean it, right? Cleaning is the first procedure. You could have null values, you could have all sorts of messy data lying out there. So you need to make it clean and process it and make it ready for the models to learn. And another important thing that happens here is identifying the correlations and the patterns or the important features in this data set. For example, for domestic routes, you could have certain features which are much more important, like you could have a different days to departure versus bookings pattern for domestic versus international. For certain set of routes, you might see that certain length of stays or certain advanced purchases have a very unique correlation with the demand. So those are the kind of feature and feature extraction, feature engineering that we also take care in this part.
Sharath, we were talking about data pre-processing part for dynamic pricing, and now let's come into the most challenging aspect, that is data modeling. Can you please explain what is the most challenging aspect when it comes to data modeling part?
Yeah, sure. So this is the most exciting part for us, where we actually do the modeling. So you're right, like now we have a very perfect clean data done pre-processed and everything. Now we have the job to label this unlabeled data set, so to speak. So this is truly an unsupervised learning problem. And what we do is we have a job to assign cluster labels or the demand labels for each row in this data, right? Like each booking or each shopping. So we could probably go from, let's say, 11 being the highest demand cluster to 0 being the lowest demand cluster, and all the other points fall in between these two. So we have a lot of clustering algorithms that we have in place, and we do this clustering at various levels. It could be at a route level, it could be at a flight level, it could be at various levels. And then we look at the features that are important for that particular route, and then we assign these labels. And then we come up with this grand data set which is perfectly labeled to the best of our capabilities. And then we let the classification models learn these labels. From which are actually output from the clustering models, and then that's what actually turns out the demand probabilities later, which we use further for pricing.
To make it more clear, let me ask you a real scenario. If I'm flying from London to New York next weekend, how you are able to provide me right offer at the right time?
Okay, so let's add another layer of complexity to that. You're traveling from London to New York next weekend, but you're staying there for 7 days, and that includes a Saturday and a Sunday. And this is where it becomes slightly complicated, and that's where the beauty of ML also kicks in actually. So for each such request, we actually map the demand label, right, using clustering, like I said earlier. And then we have a unique approach in our dynamic RM, which is for each such request, we also assign a score which we call as the travel experience quotient. So this travel experience quotient, or this methodology, is built on 5 pillars, if you will. One is the historic context that we talked about here, which is where the clustering demand happens. Then we add the context of load factor, what's happening right now, right? Like how many seats are sold in the airline today and how many is actually left. So that's a load factor context. Then you have the surge pricing context. What if you have a Super Bowl or some expo going on? There's a different situation kicks in there. Then you have the reinforcement learning, where the feedback loop, the live feedback loop of what's happening, that's where the live scenario kicks in. You could also have the competition data context, so how the competition is actually reacting to your prices and how would you want to adjust this. So these 5 factors come in, and then we actually provide a score for each of such product, and that's what drives the final price.
But how accurate this demand forecasting will be, especially in today's pandemic context?
Yeah, you're right. The COVID pandemic has disrupted the airline industry, as everyone knows, and it has disrupted the forecasting model for almost all the industries. And the demand forecasting that we talking about here, and the demand forecasting from the historic context especially, is not going to serve the purpose of dynamic pricing. Relying on that alone would only serve as an Achilles heel. So what we need, or the demand forecasting in the historic context, what we mean here is we look at the historic context of pre-COVID as well as the post-COVID data. So both are included in this demand forecasting from, when I say the demand forecasting from historic context, because we still need to know the seasonality from the pre-COVID trends, like what happens on a Thanksgiving, the New Year's, and different holidays in the different countries, etc. But at the same time, we also need to know the recent trends from the post-COVID data. So both are given weightage. And then, as I said, we add the load factor context, the reinforcement learning, and the surge and the competition, everything, and that's how the final price comes in. But yeah, you're right. So the historic context itself will have weightage for pre-COVID pattern as well as post-COVID patterns.
Awesome. What do you envision as an end state for airlines with dynamic revenue management?
Right. So we have a revolutionary vision for airlines. We truly envision a classless inventory management system.
Okay.
So we can get rid of all these predefined rule settings and everything. The rules can only take you so far, and the AI era is going to explode in the next decade. So we are only scratching the surface, as they say. And a very important point I want to touch upon is the kind of research that is happening right now in AI is mind-boggling. That the number of libraries that are coming out, the universities that are researching on this. So it's every day something new is coming out. So it's a consistent learning process. The airlines also will have to understand that. I'm sure they know this. So this process has to go on. This journey has to carry on. And I truly believe that the barriers of universities and academia and the corporates will shrink with this kind of an AI explosion that we're going to see in the next decade and many more years to come, actually. So that's where truly the merge will happen, and that would be a very exciting place to be for the future.
Really interesting. I am very excited about this AI-driven dynamic revenue management. Thank you, Sharath, for all your insightful comments. I'm looking forward to a lot of new stuff that's coming out.
Thank you, Sujit. It was wonderful. Glad that you could take away something from this discussion.
Thank you. Hope everyone enjoyed this video. Tune into this space for more such videos where we discuss how technology can transform the airline industry. Thank you for watching.